the sound audio. All right, let's start with traversing the DOM. Right, so the DOM is UI. Node.js is backend server. Yeah, pretty much. It serves up pages, but it's pretty powerful, pretty cool actually. I'm actually looking forward to getting into that content because we'll be able to take advantage of what we learned in the last little while, and some very cool stuff there. You're using a server, so there's a lot more powerful stuff that can happen. And those of you may probably like that. You can actually do some really cool gaming with Node.js. It's actually, if you're interested in that kind of thing, you can make some pretty nice little gaming things with it. Using something called WebSockets. Anyhow, we'll get there. Let's get through this though. We're working with the DOM and the HTML representation of that, and it may seem a little long in the tooth, but you need to know how to do it, because when you tie it in with events, standalone, it's what it is, right? Traversing the DOM, manipulating the DOM. But when you add events to it, then you can make some real crazy stuff happen. Again, you could even build gaming stuff where you click on a square and the square disappears and all that kind of stuff. Actually, there's tomorrow's lab, I want to actually give a tutorial, which is just one I found that's pretty cool, and you build like a little tiny game, which is like clicking on squares and stuff like that. Interaction with the DOM. But we gotta learn this stuff first. So traversing the DOM, meaning navigating through that big tree to the bottom nodes, if you can. Concept of nodes. The parent node, you can also access children nodes, and then when you have a child node, it actually may have sibling nodes, which are like adjacent nodes, right? So you need to be able to hop throughout that tree. jQuery is awesome for this kind of thing, but like we established already, there's a whole bunch of built-in vanilla JavaScript that we can use without having to use a library, such as like query selector and things like that. So traversing basics. Now remember this whole box model from CSS. We remember this, that boxes were within boxes and boxes and boxes, right? We have each element is a box that has padding, margin, border, and then sometimes that element may be inside of another box, right? That was the box model, if you recall. When we look at this DOM tree, remember, we already remember from past session, the DOM tree is that kind of object model that is represented over that HTML elements, right? The HTML elements on their own are basically don't really have any functionality aside from markup, and then the browser kind of overlays that gives you all of those features that you may need to work with, right? So we call it the DOM tree. So, in order to explain that basic idea, since people understand the idea of tree, right? We understand the concept of a tree, branches, sub-branches, nodes, leaves, all those types of things. Infinite hierarchy of branches. This is a very simple tree, but you can only imagine. I have to get a tool, actually. I'd love to get it, because there can be thousands of markups of pages. To actually translate that into something visual is really cool. I know there's things out there. To be honest, I haven't really used it or need to use it. Probably it's more of a UX kind of thing. But you may not even really need that whole visualization representation of the tree. If you're really good at reading the markup, you can kind of visualize it. But two concepts of the DOM tree: the containment and the order. So containment. Parent elements contain child elements, right? And those children may contain other child elements, because we have many levels of nesting, and that's where it gets really crazy, right? You need to be able to be really good at selecting. Again, I go back to jQuery because that's what I'm really familiar with, and you may need to do some really very in-depth selecting and dynamic selecting if you need to change. Have an interactive, I don't know. I remember building some guy wanted if you can imagine this, it was in a investment brokerage place, and he wanted the website, he wanted the web page to remind him of Excel. We just said, well, why don't you just use Excel? He said, no, I need it to be on the web. So we had to make that grid. That was like 100 row, 100 by 100. It was ridiculous. But we needed to manipulate all those cells using, I had to use jQuery, but oh my God, it was a nightmare. And things had to change, and you had to remove stuff, and stuff had to be highlighted. And wow, that was a crazy experience actually working on something like that. And you really appreciate selectors and how you can actually navigate through something like that. Also important is order. DOM elements have a definite order that you can manipulate, right? You can start from the top, go down to the bottom, and keep traversing. Start from the bottom, go to the top. If you have a situation like this here where you have a parent, which is a UL, which is an unordered list, and you may be able to grab the first LI, which would be a child, direct child, then you'd be able to hop across to the siblings and navigate. If you started at the last sibling, you'd be able to find the adjacent ones and then navigate up. And then once you grab this guy, you find this guy's parent, and then you can grab onto the root element, maybe even traverse down the other side of the tree if you needed to. You may not actually need to do that kind of big traversal based on, it all depends on what you're working on, to be honest. Just know that any of these nodes you can manipulate, right? If I click on the UL, I could blow away this entire section if I wanted to and make for a really crazy experience. So if we want to really visualize traversal, this is a good example, really. So if you had a quick diagram here, the first 3 months of 2018, I just picked 2018, why not? Probably is a leap year in there, maybe not. In this case, the year contains 3 months, each have 4 weeks. So in this little scenario here, you can tell the year is the parent, there's children, which are months, 3 months, each of them have 4 weeks. And that's kind of like a nesting. And we may need to traverse all the way down to that week number 1, which would be the first week of the first month of the year 2018. So HTML equivalent. So for that example, each month is a div, right? So we can visualize that each month may be a div that only has a class of months. So we may have on these things like a class attribute that we may be able to select, right? Using our selectors would be an easy way to be able to grab that. The name of the month, if we had a selector on it, we could instead of traversing all the way through that list, we could actually grab onto all 3 months and then kind of navigate down. Same with the year, we may have a class year on it, so we could grab that as well at the top. So if you really to visualize a way of representing this in HTML, you could have an HTML node that's the top that has classes year. The year may not actually have any styling to it, but it may allow you just to select multiple. Same with these, they may have classes on there, again, not IDs, because IDs would be unique to the element. You may need to select all the months. Same with the weeks. So you could have flexibility to grab all of those elements that may have those classes on it. Remember, these may not be the same elements, meaning the year may be a div tag, whereas the weeks may be something else. Maybe they are table rows inside of a table, but in order to select them all, that's very common actually. Sometimes developers will throw a class name on with no intention of giving any style. They'll just apply it so that they may be able to select it. So it's like an empty style, an empty class, but it doesn't matter. The browser will accept it, and then you can use it for your selections. It's an easy way of tagging elements, and you could do it in that kind of situation, right? Like we said, the weeks don't have any particular identifier beyond a class, so you could see why you'd want to use that. So using classes and IDs to access elements of the DOM, we can also use the relationships. So we can use those quick lookups, like we did in Tuesday's class, where we actually grab, get element by ID, or use the query selector that's probably the cleanest, easiest way. But there may be times where you need to get the child, the parent, and the sibling, right? So you may need to drill down because maybe those elements in that relationship don't have a class associated to it. So in here, you may have a child element here. So the child element is contained within another element. So right here, if we just focus on the month January, that is the direct child of the year. So the January div, we could say, is a child of the year 2008. Of course, January has its own children, which are the weeks. And I'm sure if you looked into the weeks of the calendar, you'd actually have a day. So again, a parent then has a parent child, and then this parent child has a child element as well. So has one child which has many children. And we may need to have access to those really quickly without having to look them up, because we may not have selectors on those. We may also have the concept of sibling elements. So an element that has the same direct parent as the other elements, and they're beside each other. So in this situation, January, 4 weeks all 4 weeks within January are siblings of each other. So we have the parent month, and we have those adjacent child siblings to them. So the difference between HTML and the DOM, we already kind of talked about that already. So if we did think of it as a personal calendar, the calendar is just a record of things that you do during your days. It's not the actual activity. In other words, it's the model of the stuff that goes on during the day, right? So the DOM is the model. The DOM is the activity that goes on. HTML is the content of your day. It's the markup, right? HTML elements make up the web page, where the DOM is an accessible interface to direct changes, right? So the HTML element is the HTML static markup is just that. And as we said before, the DOM is like the overlay of the object model on top of it. Right, so let me see here if I have my browser, not my browser, sorry, so I have Traversal here. Okay, so we're getting into some of parent nodes. Hold your horses on that one. Let me go back to the browser because I haven't talked about the parent node yet. Right, so we may need to get the parent node and then drill down. So there's a way to actually do this, again, using our web docs and our document interface. So if you get the parent node, a specific node in the tree, you can use the parent node property. So if you get a HTML node in the tree, on it is a property that is a link back to its parent. So there's always a link up that tree. So if you grabbed onto 1 week, the first week of the first month, you could inspect its parent and navigate back up to its parent. You could actually grab onto it. It's read only. So the document and document fragment nodes do not have a parent. So there are some nodes that don't have a parent. So you have to remember that there can be cases where this could be null. If you wanted to create a new node but haven't attached it to the DOM tree, that parent node of that node will also be null. So you can create an element, which will show you how to create an element. But if you don't do anything with it, then its parent will obviously be null because you haven't attached it to that tree. So now we're talking about branches of a tree, and you want to add a leaf to the branch. So there's ways to create a leaf, but you need to attach it or append it or insert it or do something with it. If you just have a leaf that you've created, then it's just a standalone leaf. You know, it's in your hand. It's not part of that tree. So therefore, its parent will be null because there's no branches that you've attached it to. So that's a case where it would be empty or null. So if you actually have a leaf or a node that you would like to attach, you know, there are mechanisms in the next second part that we'd show you how to do that. So here we have some example of a HTML document, a nicely formed HTML document. And we have just a simple node here. which is given by the ID equals to main. And then inside of that, we have a child element, which is a paragraph, which has a class of note. So it's nested. And again, we have the script. This is a case where we would not want this script to be in the head tag because the head tag is rendered first before the DOM tree. So we would never, this would be empty. It would never run. So basically what we're doing here is we are grabbing on with using our query selector and using a class selector, right? The dot notation and the note corresponds to this class right here. It's going to scan class, going to grab this element. So the return of the query selector will be this element, which will be placed and assigned in this variable here. So this note value will essentially contain this whole line, this paragraph. And then when we want to console log that element dot parent node, then we can expect, we would hope that it would actually return the div tag there. That's the expectation, right? So let's turn off my pointer and see. I believe I have something like that already set up. See if I go into where we're doing traversal, and we were looking at the child node here. Sorry, parent. This is a note. If I go to inspect my dev tools, I would hope that if I look at my console, and there you see it there, you can see that it did actually return that whole element there, which is the div tag entirely. It basically returned that whole element. So it went up a level, it went up, kind of followed the branch, and it returned that element there. So that's what it looks like, same deal. So again, it just selected in the same way, and then we had access right here to it, and then by accessing this, we get a kind of a read-only element of this whole piece right here. Very simple kind of element there, but that it shows you how you can navigate upwards, traversing the DOM upwards. All right, let me break it up a little bit with our friend. Honestly, I don't know his name. We'll just call him the Ninja. Again, let me know if you cannot hear this. Sorry for the commercials.
Hey gang, welcome to your 6th JavaScript and the DOM tutorial, and in this video we're going to go over the concept of DOM nodes. Okay then, so before we go any further with this series, I want to clear up the whole concept of nodes in reference to the DOM, because it's a concept that's going to creep up in several different methods we'll be using as we go forward. So I think it's best that you really understand what I'm talking about when I say a node, and we're going to look at some of the different node properties we can use on elements in this tutorial as well. So pretty much everything when it comes to the DOM is a node, right? Everything in this document right here is a node. The HTML tag, the head tag, the body tag, every single element in this page is a node. And when we reach in and we grab an element, we're reaching in and grabbing that element node, right? But elements are just one type of node. There's many different types of nodes. Another type of node is the text node. So this thing right here, this is also a node. Another type of node is a comment. So this is a node, this comment right here. And another type of node is an attribute. So something like this here. So there's many different types of nodes. So I'm going to demonstrate now how we can find out these different node types and display some information about them. So I'm going to come over to the text editor, and the first thing I'm going to do is reach in and grab an element, and I'm going to grab the banner. So we'll store this in a constant called banner and set it equal to document.querySelector. And then inside we want the page hyphen banner. So that, my friends, is this element right here, page banner, this big grey block over here. So we're grabbing that element now, and we're going to find out a little bit about this node. So the way I'm going to do this is by logging certain things to the console. So I'll say console.log, and the first thing I want to log is the node type. What type of node is this? So I'll say page hyphen banner node type is, then I'll do a colon. After this, I'm going to do a comma to log something else to the console, and I'm going to say banner, which is this constant right here, and the node type. Okay, cool. So let's save this and check it out over here, and we can see that page banner node type is 1. Wonderful. That reveals an awful lot to us. So instead of giving you an actual word, they're giving you a number. And all of these different node types have different numbers. But fortunately, we can easily find out what they mean. So we can see right here that node type 1 is an element, and it is in fact an element because it's the page banner. We can also see that type 2 is an attribute, 3 text, etc. So we can see all the different node types here based on their numbers, right? So if you ever get stuck, you can find out those here. I'm going to leave the link to this page down below. Okay, cool. So that's how we find out the node type. Now I'm just going to copy this dude right here, and I'm going to paste it down below. So this time what I want to do is output the node name. So I'll change type over here to name, and change this to name as well. And let's see what this does. So save that. And this time we get node name is a div. So what this does is return to us the element name, in which case this is a div, not this one. This thing right here, where is it? In the header. Page banner is a div. Cool. So we found out the type of element that this is. So we do that by using the node name property. So another thing we can do is also find out if this node has any child nodes. Therefore, these things right here, right? So the way we do that is using a method called hasChildNodes. So again, I'm going to paste this down below, and I'm going to replace this with a method this time. So these two are properties. This time it's a method called hasChildNodes, parenthesis on the end because it's a method, and I'll replace this with hasChildNodes. Save it and check it out over here, and we can see page banner has child nodes, true. So this method returns either true or false, right? If it's true, then it does have child nodes. If it's false, then it doesn't have child nodes. So I want to show you another method now, and this method is going to let you clone a node, right? So we've reached in and we've grabbed this banner right here. Now, if we wanted to, we could clone that entire node, and then later on down the line, we could insert it somewhere else on the DOM. So the way we clone a node is dead simple. I'm going to create a new constant, and I'm going to call that cloned banner, and set it equal to banner dot, you guessed it, clone node. And we need to pass in true here. And the reason we pass in true is because we want it to go deeply into the node. So if we didn't pass in true, then all it would do is create this div with an ID of page banner, and it would disregard every child node inside. It wouldn't give us the nested content. If I pass in true, then it's going to give us all of this nested content and clone all of that as well. So it clones the entire thing rather than just this one single element. So I can now log this to the console. I'll say console.log, and then we'll log the cloned banner to the console. Check this out. Now we have this thing right here, and we can see all of the nested elements. Now, if I was to pass through here false, save it. This time we see just that div with an ID of banner, and it doesn't have those nested nodes in it. So this has to be true if you want to get the whole thing, right? So later on, I'm going to show you how we can insert elements into the DOM. So what we could do is clone a node and then insert it somewhere else. But for now, we've not learned that, so I won't do it. Okay? So I just wanted to clear up this whole concept of node. I've not gone too deeply into it, but you can read more about it. Just so you know what I'm talking about when we say child nodes or parent nodes or sibling nodes, that kind of thing. So know that in the next tutorial, what we're going to do is move on and find out how we can traverse the DOM, move up and down from child nodes to parent nodes and vice versa.
All right, actually, that's pretty awesome. Let's take a look at that one. Clone node. Again, as I said before, I'm not going to go through all of the API because that would make for a pretty exhausting session, to be honest, just to go through all of this. On the node, so there's the clone node method to duplicate it, to duplicate a node on which the method was called. So it gives you an example as well. That's really cool, actually. If you look at the web APIs on the node here, the DOM, actually, I should include this. Here you go. So I'll put that in the channel actually when we go to the labs. But this is the API a lot. I think I had a link to the document there, but it should be this API for the node. And again, same thing. Like there's a whole, look on the left side again, all the properties: child nodes, first child, last child, the name, the value, the type, parent element, all these things, previous sibling, the text content, all of this stuff. Of course, then when we get into manipulating the DOM, not just traversing, not climbing up, crawling up and down, then we would deal more with the methods, right? How do you append, replace, remove, you know, all these kind of things, insert. That's the second part. But we want to establish first what the node is, and then all the properties within that node for traversal. So we're going to get into child nodes. We're going to get into, yeah, we're going to continue on. But so we established what a node is. Not to be confused with Node.js. Node.js is something entirely different, and Node.js is a different kind of node. It's not a document object or a HTML node. That has a different context. Child nodes, we can already kind of establish what they were. So, but you have that access to the child node in that property. So to get a live list of child elements for the specified node element you have, you can use that child node property. So you have the parent element and you have child nodes on it. Child node property returns all the children with any node type. Doesn't matter what it is. Doesn't matter if it's a div tag, if it's a comment, if it's a text, if it's media control. If it is a node that's part of that parent, you're going to get it. And if you just want to get the child element with only the element node type, you'll use the child property. So you got to look at that difference there. There's child nodes and there's children, right? So there's child nodes and children. So if you want to look at the properties inspected a little bit more, we can see here on the properties list, we have, where is it here? Where is it here? Okay. Children. Where was it here? Okay, I gotta put a link in there. Child nodes. Let's look at child nodes first. Child nodes give us more information to what we need. Child nodes. The child node API. Here we are. Right here. The child node mixin. Mixin contains methods and properties that are common to all the nodes of the node object that can have a parent. So here is, I guess, on top of that child node, you have all the methods on top of it. Actually, that's not the one we wanted. Web API, child nodes. You gotta really dig through this stuff here. Node dot, anyhow, I'll look that one up. It's part of it. Probably paste it, it's probably better. But anyhow, there's a difference between those two, right? So when you play with it, the child nodes property will give you more of context to what you want. With using the child, then you get a stripped down version with only the element node type. So if you have a calendar here, January, and we have these 3 children. If we wanted to grab the first child of that node, we have that property for first child. So it's, again, read only. It's going to return back the first child of that list. So to get the first child element of the specified element, use the first child property of the element. If the parent element does not have any children, then the first child will return null. So if in fact there is no children, it's going to return null for you. It's not going to throw an error though. It's basically going to return nothing, right? Because null is basically like empty string, but it's not going to return undefined. It's going to return null. Or to get the first child with the element node only, you can use the first element child property. So again, first nodes here, first child nodes of each month. And then obviously, if you wanted to get the last child, the same thing applies. You can use the last child. So if you have a parent element, you want to get that last child, you can get that. Or get the last child with the element node only, use the last element child property. So even to myself, when I'm looking at this, I got to run this in code because I get confused also at this. I have to inspect the output. And when you inspect the output, you have more context to what that is, right? So if we have the child node here, so here we have a markup here. We have a bigger document here. Well, the script tag is bigger, but we have a menu tag. And you can see up top here, it has an ID, which is menu. And obviously all of these are the children. If you could represent it as a tree, obviously menu would be the top, the UL, and then these would be the children. And then they're siblings to each other, and they have some different attributes. They have a class. You could do some other selections here. So first of all, we need to go and we need to get it. We need to get that element by ID, and I didn't use the query selector. I used the old school get element by ID. And then I list out all the child nodes using menu.childNodes. If I want to get the first child element, then I actually get that first child and I log that out. So let's look at this for a second here, step by step. Let's comment this out. Let's comment this out just for our sake, and we'll look at it one by one to determine what the difference is between both of them. So if we were just run this one here, child node, let's take a look at this, and we'll look at it in our browser using our Chrome tools. Let's look at the menu in this fashion, use DevTools, and we'll put it to the side just so we can inspect it a little bit better. So if I put a docket to the side, all right. Inspect the tree, it's as we would expect it in this format here. So when we console log all the children, we're going to get a big list here. So you can see here it's giving us everything. It's giving us the text. So it's breaking up in this way, all the nodes. So if you look at it, it's giving us text, the first LI, the text, the next LI, all the elements in that tree, right? So it's basically giving us all these elements here. It's not just it's basically giving us this first LI tag. It's giving us some text. It's giving us an LI tag and some text. So it's giving us a lot, right? So you may need to drill down into some of those things. So here we're going to get the first child node name, and we're just gonna console log it. Let's take a look at this. So if we refresh our page here, using that in the console, we have text because it's getting the first child node name. So if I just get the first child, let's refresh it. We have a text element that has a lot of information on that, and that in fact, if we drill down into what that is, where is that one here? It's some white space, I believe, because it'll actually return some of that to you. So if we drill down deeper and get the first element child, so again, another property. So instead of doing first child, we do the first element child. Let's see what that gives us when we refresh that. So that gives us what we want. That gives us this element, which is this LI. That's what I really wanted. I wanted this marker with the home. So that's really what I'm looking for, to be honest. So that's very specific. I want the element, the child element, not the first child. As you see, text is the white space created by a text node, the in between. So that can get confusing, right? There's some additional white space in there between UL and the LI. So it's gonna maybe it's somewhere in there we can't see it. That's what's confusing, and that's what's giving us this white space right here. So we don't want that. We want the first element in the list, and that's what this LI is. So if we look at the node list, you'll see white space, the first LI, white space, first LI, white space, right? So we may need to ignore all of those, and that's going back to that slide, and that's what you need to see sometimes when you're looking at the code. When you say get all the children, it's going to return to you all of this, the white space included. If you get child elements, it'll return back the list that you would expect. Yes, sometimes it means walking through the code a little bit to understand it. To be honest, I understand code more than actual text. So if we wanted to get the last child, probably it may give us the exact same type of situation where it may return back that text. Yes, it does. So that must be the white space that happens after the UL and the body, somewhere in there. That's the white space. So that's not really helpful to me right now in this demo. I would rather return the last element child. So by using that, then I can actually get access to what I want. This is what I want, the about us. And I want to look at that in some way, right? And I assigned it, I believe, last child element. No, we didn't actually assign it. we could assign it and give it dig into the changing the type or what we needed to. If we wanted to assign it last child element equals to menu dot last child element. Here we go. And then we could actually, output the variable instead of directly last child element. There, refresh. And then now we should be able to pull it out of this console right here, right? So then we could actually dig into its properties now. Let's look at the inner text. Now there's a property called inner text. So if we, and we'll talk about this in a little bit, inner text. So now that's the inner text, the about us. That is represented of this context right here. That's the inner text because it's the content within the tag. As we learned with our HTML tags, that's the content of it. However, if we wanted to get into something else called, let's see what the inner HTML might look like. It may be nothing for this. Let's see. Yeah, it's nothing because there is no inner HTML in that tag. But what if we actually had this wrapped in an old school tag like a bold? I don't know if that's old school or depreciated anymore, but that was an old school tag. It's been around for a very long time. Let's look at that for a second here. So if I refresh, this becomes bold now. And if I were to do the same thing as I did before, the last element text right there is the string about us. However, you can see it's stripped out. If I look at the inner HTML, it's going to give us that bold tag that's there. So it's actually the inner HTML. Now, I mean, you can modify all of that as well, right? So if there's different ways that we may be able to do it. It may not work here directly. Yes, it did. Okay, so if you see that, I'm actually modifying that on the fly, and the DOM is actually updating, right? I could actually go in and change that HTML as well if I wanted to, like, we could get really, let's see here. We'd have to put it in a string though, right? We could put something like a div tag with y, what have you. Let's see what that looks like, if that'll work. Yes, there you go. So you can imagine if we had some styling on part of it, we actually could change the attributes as well. Let's see if I can do it inline here. What can I put here? Color is red. See if that works. No, that didn't like it for some reason. Yeah, there's a way that you can do that. It probably needs some inline. Anyhow, this is not the really preferred way. There's ways of changing attributes a lot better, but just know that we can change it on the fly. We can change, when we are dealing with attributes, we could in fact change that color. It's probably a matter of just playing around with that in a little bit. Probably I got it wrong here somehow. Yeah, but anyhow, that's how we dig into some of this stuff. So that's what that context is for the last. So when you see this, somebody is messaging me, I'm probably missing something. Escape the double quotes, you're right. I need to escape them, and I will do that. Right, so that's the confusing thing to note. Okay, so when you're looking at these examples, and I needed to show code to really explain it. When you're dealing with the last child, it's going to return everything, or the children. You need to dig into the element, and it's going to return back that HTML that you might expect. And the other thing to note is if you see that text, that's the white space. So don't let it throw you off. It will most likely throw you off quite a bit. So to recap child nodes, so the first child and last child return the first and last child of the node, which can be any node type, including, and that's what caught us a little bit, the text node, a comment node, or the element node. So it can be anything. The first element child and the last element child return the first and last elements. When we mean elements, we mean like an HTML element. This is tricky, honestly. The switching between node and elements, right? It can get very tricky. You may need, again, to code and try it yourself to get it right in your head, because even when I think about it in context, it's like, why is it returning this? That's not what I'm expecting. But in programming, you don't always get what you expect all the time. Child nodes returns a live list of child nodes of any type. We did that already. But then if you use the child elements, that's going to give you all the element tags. So play around with this because I guarantee you will get caught up on this. You will come through this problem a lot. So come to know what it's about. So we'll have a couple more slides, but I'll break it up again and give you this guy. I actually like this guy. There's a couple other guys out there like Mosh, who's pretty good. There's a guy named Brad Traversal, which he moves at a faster pace, to be honest. So like I'll pick him up and look at some very complicated Redux stuff or something like this. But this guy does a good speed. So let's look at this guy again.
Hey, would you like to learn to code by making computer games?
Not this
My name's
guy.
Ben, and I've
This
already.
guy's too fast.
Howdy campers, and welcome to your 7th JavaScript and the DOM tutorial. And in this video, I'm going to go through DOM traversal from parent to child and vice versa. Alright then, so now you know what nodes are and what they do. In this tutorial, I want to focus on how we can traverse from one node to another node in the DOM. So say for example, I have in my JavaScript file a reference to this element node right here, the book list. And from there, if I wanted to, I could grab a reference to its parent node using a property or its children nodes. So I'm going to show you how we can do this now over in the text editor. The first thing I want to do is grab a reference to this book list over here. So I'm going to create a new constant, call this book list, and set it equal to documents.querySelector. And inside we want to pass in the book list. Okay, so now we have a reference to this element, and I want to traverse from there to its parent elements first of all. And there's two different properties we can use to do this. I'm going to log both of them to the console. So I'll say console.log, and then inside I'm going to output the parent node is, and then after that comma, and we're going to output the parent node. And the way we do this is we grab the node first of all that we want to find the parent of, which is book list, and then we say ta-da, parent node. Very surprising. Okay, so this is going to go out and grab a reference to the parent node of this element right here. So if we look in the console, we can see that the parent node is this div element with an ID of wrapper. And inside the element tabs, we can confirm that. There's the book list, and there is the div with an ID of wrapper. That is the direct parent of this dude right here. All right. So we can also use a slightly different property to output this, and they're both going to do pretty much exactly the same thing. So parent elements instead of parent node. That is it. So I'm going to output this to the console as well, and then if we go over to the console, we can see we get it output twice. So about 99 times out of 100, these two things are going to do exactly the same thing and return the same element. Now, if we wanted to, we could kind of chain these together and go one up again. So I will do that. I'm just going to say dot parent element again. And what that's going to do is first of all find the parent element of the book list there, then find the parent element of that. And we're grabbing a reference to that. So this time we can see that we grab the body. All right, so we've gone 2 levels up. First to the wrapper, then to the body. So that's how we can traverse upwards through the DOM using these two different properties. Now let's have a look at how we can traverse downwards to children. And the behavior of this is slightly different. So what I'd like to do is first of all, log to the console all the node children. So we'll say console.log, and we're going to log book list, and then what we're going to log is child nodes, like so. All right, so if we save this now, we can see in the console that we get this collection right here, and it's got text, then H2, then text, then UL, then text. Now, what is this text stuff right here? Well, if we take a look, we can see in here that we get this kind of arrow, which represents a line break, okay? So whenever we get all the child nodes, it's going to return the line breaks as well. So when we have an element, first of all, we have a line break to go to the next line. Then we have the element node itself, then a line break, then the element node. That's what these things are right here, the line breaks. So normally we don't really want to grab those, do we? So we can also get the child elements, and the way we do that is by just saying .children instead. So if we save this, then we can see this time we just get the element children and not all those text nodes as well. All right. So there we go, my friends. There are some different ways we can grab hold of the parent nodes and the children nodes.
Be honest.
Awesome. That's Yeah, I like those little 5-minute videos, breaks it up. Yeah, but as he noticed, he said that, yeah, it white space, but the line breaks in there. You know, that's actually pretty cool when you actually look into some of this. When we look into that output there, it'll actually tell us the, it'll actually tell us that. It'll give us the, where was this number 2? Am I looking up? It'll give you the line breaks in there. That's pretty awesome when you actually inspect that stuff in here. So when we look at this full list here, if you really expand that, it'll actually that's, you know what, right there, those little line breaks, those bent arrows or whatever. You know, to be honest, I looked at that earlier and I was like, what are those things? You know, so you always catch yourself sometimes. So it's actually a cool thing that that was explaining that. And also the parent. I've done that many times, right? You could actually have a very deep tree, and you may need to, you know, you may need to do the parent element dot parent element dot parent element dot. Oh my God, you can actually keep traversing upwards. You could probably do like a while loop, checking the parent. Are you at the top? Are you at the top? Are you at the top? Does the parent have null? Then you could traverse all the way up the tree, doing some crazy thing. I don't know what you do. Maybe you'd want to, you know, I'm sure spiders, if you don't know what a spider or a crawler, not in the literal sense, but a web crawler or a web spider, what they do is they, from an external source, they'll pull a website and they'll start to break it apart. And then that's how they, you know, search engines probably do that, how they actually navigate to the pages and they pull out the content for ranking. And they basically, they can tell whether or not the page has been updated or not recently. Basically, for their listings, you know, that you may submit a site, just the initial index page, but there may be nested pages in there, and these spiders crawl throughout the site, pull out content, and then if it's a very you know, a page that's updated recently, or you know, there's good content to it, it'll actually rank those pages and list them in their listings. There's a whole, you know, this is SEO, search engine optimization. There's a whole bunch of, so if you're dealing with search engine optimization, these crawlers look at the header tag with the metadata. So if you describe your site really well in that meta tags with the keywords, if you've never done this before, this might be brand new for you. If you have, then it's very straightforward. But you know, they look at the metadata of a site, and that's how they up their rankings, right? If I go back to this site that I am familiar with, if you really look at that DOM tree and you look at the header, I'm sure inside of here, there's some very good, somebody has spent a lot of time, I would hope, inside of the meta tags. So here we go, meta tags, author, Indigo Books and Music. It has some properties for Facebook, Twitter. I don't know if those are just links to it. And then there's some other kind of information. We have all our other kind of things going on. They may have an external source for some of their metadata, but you know, I remember being working at, oh, there you go, here we are. So they insert a lot of stuff. So I searched Dr. Seuss. They kept it in the page, the description. There's a very description of what's going on here about the content of the site is a browse and shop for home decor, gifts, and so on. This would show up in a search engine optimization when you actually search for that site. Probably pull out that description. So anyhow, just know that, yeah, there are such things as crawlers and spiders that actually break apart and navigate through the whole tree, and they pull out key pieces of information. They may have algorithms that use JavaScript, I'm sure of it, that do certain things like this. So that'd be like a real life example of why you might want to traverse a tree if you work for a company that has a crawler. So we're almost done. Sibling nodes. Sibling nodes are, you know, like we said, would be the weeks of the, you know, the different weeks of the month. Obviously, are siblings. Same deal. You have next element sibling, and you can go to the previous element. So you can actually jump. If you're in the middle, you can go to the previous one. If you want to go to the next one, you go next. All right, so let's see what I have here for that one, sibling nodes. But you guys will probably get to some of this soon. So same kind of deal. We have this going on. If we inspect this, so I imagine my expectation is that if we can grab onto one of these elements here, whether it be this middle one by the class, we can navigate to the next sibling, or we can go previous. Let's see what we did here. Let's take a look at the code. So in this example here, we have this selection here. And let's just kind of space this out a little bit. Right. Again, for some reason I'm mixing and matching. So I mix and match. First, I get the menu. I get the entire markup, and that's represented right here. So I have all of this. I have all of it, and I want to do something with it, but I'm console logging it. And that's stored in the menu, this variable. So then I want to get the current. So now I want to pull out this one right here. So I'm not using the child selectors. Sorry, I'm not drilling in by the parent.child. I'm actually using the query selector, and I'm actually querying by the class selector, and I'm just going to output that. And that's what the second one is. I should have probably console logged the description, but I didn't. So now I have access to this right here. I could change the text. I can do other things too, right? Maybe I could, once I learn events, I could actually attach an event handler on there or event listener, meaning if I wanted on the fly to attach some mechanism where if somebody hovers over that customer support, it's going to highlight, or it's going to do something crazy. It's going to highlight red. I could certainly do that on the fly if I wanted to by selecting all of the markers that have current on it. Right, so then I wanted to get the previous sibling. So I am using right here, current dot previous element sibling. So I'm expecting here that if I selected this one here, the current, then I'm going to get products, right? So if I go, I look at this one here, I have products, right? And I imagine that the other one is going to be the next element sibling, which is right here. So then therefore it should be careers, update your career. Right, so there we go. So and again, if I wanted to get the parent, so here I have this current, I wanted to get the parent element, you know, my expectation is that I could get that menu by, if I go menu dot parent element, that I could actually grab onto that menu again. Oh, actually, sorry, I grabbed the menu. Okay, no, if I wanted to get the current, sorry, my bad. If I should get the menu from that current one, so if I'm here, I want to traverse up to here, and then maybe I will get the parent of that and traverse up to the body. But let's see that work. So there, I have the menu, great. But now I want to traverse up to that body, so I will also chain it. So there's something called chaining, right? We use that accessor again, that dot operator, so we can go one more level up, parent element. So now I would expect that from here, I've traversed upwards to here, and I've traversed up to that parent, which is the body tag. Again, we don't have any mechanism yet to trigger a page refresh. Our event is the hard refresh. After tomorrow, we should be able to, you know, incorporate some button clicks and stuff like that. So now I have the body tag. That's great. So now I have everything. I have everything here. So what happens if I chain it again one more time and I go parent element? Will it go farther up? There shouldn't be. Let's see what it is. See what happens. So what would I get? So I get the HTML. So now I'm at the top of this stack, right? So at the top. So where I'm right here, I'm at this HTML, right? Sorry, HTML. So I'm right there. I'm at the top. So what happened if I were to go one up level? Would I get anything? Let's see. Let's do it one more time. So I'm going to chain it a fourth time. Parent element, and refresh that. Let's see what that is. So now it's null because now we have no parent. Now it's basically, we have traversed from here up to here, and then up to the header tag. And as you can tell, it doesn't have any parent. It just has a sibling. Hey, let's see if we can get that sibling. So instead of the parent element, let's see if we can get the previous previous element sibling. Can we get it? Let's see. We don't have it. So we can't actually get it. Let's see. Can we get the next, or are we at the top now? The next element sibling. I guess when we're at the top there at the HTML, I guess that's kind of as far as you can go. So you can return null. So that means that's not a problem. It doesn't throw any issues, but you know, you could see how you can navigate, keep navigating all the way up. You could write a while loop, navigate all the way up to the top until the outputting everything along that branch, going back to that tree. All right, so 7:15, that was a little bit over 45 minutes, but sometimes the first one goes over. Yep, so that's a good one. Let me stop recording here.